continuity of sine functions. So now let's discuss the continuity of sine function. Now let's check what's the limit of the sine function when x approaches 0. Now the limit x approaches 0, sine of x is equal to, now we know it very well that sine of 0 is equal to 0. And if we draw a right angle triangle, then what's the value of sine x? Sine x is defined as the ratio of perpendicular to the hypotenuse. And when this angle x approaches 0, then you can clearly see at that point the length of perpendicular will also approach to 0. So that means the value of sine x, which is perpendicular upon hypotenuse, and as perpendicular approaches to 0, then in that case sine x will also be equal to 0. So that means that limit x approaches 0, sine of x is equal to 0. And this can be also observed from the graph of the sine function. You can see when x is close to 0, at that point sine x is also equal to 0. So now we have proved that the limit x approaches 0, sine x is equal to 0. And now let's try to find out the limit of the function sine x at any point c in its domain. And from the graph of the function is also clear that the sine x function is defined for all values of real numbers. Now suppose c be a real number and we have to find the limit of this function when x approaches c, or you can say we have to find out limit x approaches c sine of x. And now suppose x is equal to c plus h. And now when x approaches c, then at that time h approaches 0. So that means in place of limit x approaches c sine x, we can also write limit h approaches 0 sine of c plus h. And now what's the value of sine of a plus b? You know it very well that sine of a plus b is equal to sine a cos b plus cos a sine b. So that means this expression can be also written as limit h approaches 0 sine c cos h plus cos c sine h. And in the previous classes you have already learned that the limit of sum of two functions is equal to the sum of limits of these individual functions. So that means this limit can be also written as limit h approaches 0 sin c cos h plus limit h approaches 0 cos c sin h. And now limit h approaches 0, then sin c cos h, and cos 0 is equal to 1. So when h approaches 0, then cos h will be equal to 1. So that means the limit h approaches 0 sin c cos h can be also written as sin c plus limit h approaches 0 cos c sin h, and sin 0 is equal to 0, which means limit h approaches 0 sin h is equal to 0, and 0 multiplied by cos c is also equal to 0. So that means this expression is equal to sin c plus 0, and which is equal to sin c, and which is equal to the value of the function sin x at the point c. So that means the limit x approaches c, f of x is equal to fc. And now since the limit of the function at the point c is equal to the value of the function at the point c, then that means the given function f equal to sin x is a continuous function. So now let's discuss the continuity of cosine function. From the graph of the cosine function, you can see it appears to be a continuous function as there is no break or jump in the graph. So let's first check whether this function is defined at the point at the angle 0. Now the limit x approaches 0, cos of 0 is equal to, now cos 0 is equal to 1. And what will the value limit when x approaches 0? Now if you draw a right angle triangle, so here you can see when the angle x approaches 0 at that time, at that moment, the length of the base will be nearly equal to the length of hypotenuse. That means since cos x is equal to base upon hypotenuse, and because here base is nearly equal to hypotenuse, so that means the limit of the cos x when x approaches 0 is equal to 1. And what's the value of the function at x equal to 0? Now cos 0 is equal to 1. And which means the value of the function and the limit of the function at the point x equal to 0 are same. So that means the given function cos x is continuous at the point x equal to 0. Now let's check the continuity of this function f of x equal to cos x for any real number. Now suppose c be a real number. So now we have to find the limit of the function. Now this function will be continuous for any real number c if the limit of the function at the point c is equal to the value of the function at the point c. Now the value of the function at the point c is equal to cos c. And now let's find out the limit of the function at the point c. Now limit x approaches c, f of x in this case is equal to limit x approaches c cos of x. Now to simplify it, let x is equal to c plus h. Now when x approaches c, then h approaches to 0. So now this limit can be also written as limit h approaches 0 cos of c plus h. Now what's the value of cos a plus b? Now cos a plus b is equal to cos a cos b minus sin a sin b. So now this expression can be also written as limit h approaches 0 cos c cos h minus sin c sin h, and which is equal to limit h approaches 0 cos c cos h minus limit h approaches 0 sin c sin h, and limit h approaches 0 cos h is equal to 1, and limit h approaches 0 sin h is equal to 0. So this expression becomes cos c plus 0, and which is equal to cos c, and which is equal to the value of the function at the point c or f of c. So that means the limit of the given function at the point c is equal to the value of the function at the point c, and which is the required condition for a function to be a continuous function, and which means the cosine function is a continuous function.